Hello everyone, our team are from Wuhan University of Technology. I'm glad to have this opportunity to make this presentation. The subject of my presentation is our recently built dataset called Amazon KG. I divided the presentation into 4 parts, focusing on why and how do we build this cross-domain recommendation dataset linked to knowledge graph. First, recommender system plays a central role for many customer-oriented online services. Cross-domain recommendation use auxiliary information from other domain to enhance the performance in the target domain. Cross-domain recommendation can alleviate data sparsity and cold start problem, and it can also enhance user model by expanding user interests and offering additional value to recommendations such as diversity, novelty, and serendipity. The main task of cross-domain recommendation is knowledge transfer between target and auxiliary domain. However, knowledge transfer across different domains usually face the problem of data heterogeneity. So the first thing we need to consider is how to explore the inter-domain correlation for effective transfer. Existing methods that analyze the user cross-domain preference mostly are focused on the user-item interaction, such as ratings and clicks. The performance of this method heavily depends on the domain overlapping information. A few other works consider context set information, such as item tags and user reviews. Such information often unstructured or limited to specific dataset and may ignore the intrinsic semantic relationship of different domains. So knowledge graph, the subjection of our session today, have proven to be effective and widely used in recommender system. It has many remarkable advantages, such as multi-domain general information. It's important to recognize that KG is also a much more important site information for cross-domain recommendation, since the multi-domain general information can address the data heterogeneity cross-domain, and rich ontology knowledge can support to explore inter-domain correlation. And its well-structured data can avoid extensive manual effort. Here is a toy example of KG-based cross-domain correlation, which shows that book domain and movie domain can be connected by KG information. Therefore, we employ KG to build a knowledge-enhanced cross-domain recommendation dataset to facilitate knowledge over cross-domain recommendation. So let's move on to the dataset construction. Our dataset built on the well-known DBpedia knowledge graph and the well-used Amazon recommendation dataset by using the Sparkle technology. We propose to build the dataset by three-step manner. First, pre-link item to DBpedia entity by this Sparkle query. Second, retrieve the related triples based on certain attributes associated with a common user preference. Third, build incorrect links to ensure one-to-one matches because some problems arise in the linking process. So the final KG enhanced information contains 2 main types. First is attribute that represent related entities obtained from the considered type of item attribute relation. Second is related items derived from the type of item relations. Here is a table that illustrates the data set we collect, and we perform a simple quantity analysis of cross-domain connectivity. We also analyze several cases of common entity to visualize the cross-domain connectivity. Oh, okay. For ease of use, our dataset format is consistent with Rickable, and we have done some experiment on this dataset. So in conclusion, we propose this benchmark dataset for knowledge-aware cross-domain recommendation method, and publish this dataset on the GitHub. In the future, we think we can use the dataset from 2 points. First is since the cross-domain recommendation usually face the complex structured data, it's necessary to capture dependency over long distance in KG-based inter-domain correlation. And second is develop algorithms that are robust to data imbalance and bias. So that's all. Thank you.